So in the previous video, we have seen the classification of elements which are done by, we can say, Dobereiner and Newland. So Dobereiner was tried, but he could not classify all the elements present at that time in the form of trial, so that theory was discarded. Afterwards, the Newland also, we can say that he arranged the elements in the form of octaves of music, and then he could not classify all the elements up to calcium only classify, and further elements could not obey that octaves of music, so we can say that that theory was also discarded. At the time of Dobereiner, the 30 elements were there in the nature. At the time of the, we can say that the Newlands, there were 56 elements were in the nature. But both the, we can say that the theories could not classify all the elements present at that time. So after this, the new scientist, that is the Mendeleev, he made the table one. He made the table and he arranged the, we can say, place the, we can say, elements in that table. So that table is there. It is called as a Mendeleev's periodic table. Before making the table, he made, we can say that in that table, that vertical columns and horizontal rows. So these vertical columns are there. These vertical columns are called as a, we can say, groups. Vertical columns are there. This is called groups. Like this, there are, we can say that the 8 groups are there. In that table, 8 groups are there. And in that table, there are the, we can say that the rows are there. Like this, there are 12 rows are there in the table one. That rows are called as a periods. So in that table, we can say that the groups and periods are there. Vertical columns are called as a groups, while the horizontal rows are there that are called as a periods. So there are the, we can say that the 8 periods are there, and there are the 12, we can say, periods in the table. You can see this table on the page number 18. Okay, so in that table you can see the elements are placed one. Now when he was, we can say that the placing the elements one, he found the, we can say that the correct atomic masses of the elements one by performing some reactions one, and then according to molecular formula. Now suppose here R2O is given. Here R2O, here R is nothing but the, we can say, element present in that, we can say that the group one. So when you say R2O, you can say in place of R you can take H, you can say H2O, or here you can say Li2O, like this. Similarly, suppose if you take from this second group one, suppose if you take magnesium Mg or beryllium, it will form the BeO or MgO respectively. So like this, he found the different, we can say, compounds one, and then according to their molecular formula of the compound, he placed the, we can say, elements in that table one. So he made the law one. That law is called as a Mendeleev's periodic law. That is, the properties of the elements are periodic functions of their atomic masses. Means what? When atomic mass change, that time the properties of elements also change. But after certain interval, after different interval, again the next elements come. That element shows the properties similar to previous one. For example, if you see here, suppose hydrogen is there. Then after hydrogen, he found the lithium one Li. Li shows the properties similar to hydrogen, so it is kept below that. Then afterwards, beryllium was different properties was kept here. Then again, it found that magnesium shows the similar properties like beryllium, it is kept below that one. So after certain interval, elements are showing the again the same properties. So it is called periodic function. Periodic function means after definite interval, the element shows some properties one like the previous, and then that elements are placed below the previous element one. So they show the similar chemical properties one. Like this, we can say that the elements were there, the elements were placed in the table one. So whatever element present at that time, that element is successfully placed in the table. So we can say that he was the first scientist who could classify the elements present at that time. Now from that table we get some, we can say, more information one. So that information, as we are getting more information, that we call it as the merits of the table one. Okay, and there are some, we can say, drawbacks are there, anomalies are there, that we call as the demerits. So in that table there are certain merits are there and some, we can say, that the demerits are there. So we'll see one by one the merits of the periodic table. Merit means here we can say that we are getting some extra information from that table one. So what is the first information? We can see that the elements were there, elements present at that time. They successfully placed in the, we can say, that the table one. That was the, we can say, first advantage of that table one. Then secondly, when he was arranging elements one, he found the atomic mass of the each and every element one. Then he placed the elements in the table. So what happened here? The beryllium was there. Its atomic mass mass number was 14.09. So we can say that the Doppler and Ullmann consider the atomic mass of the beryllium 14.09. So it was placed after the boron. But what happened? The Mendeleev found that its atomic mass is 9.4. So we can say that we got the correct atomic mass number of the beryllium. It is 9.4. So it placed before the boron one. So from that table we got information that the elements atomic mass numbers were cleared and corrected one, we can say that. So that was the second, we can say, merit of that table one. Now in that table, Mendeleev left some vacant places one, and he wrote only the, we can say, number one, 44, 68, 72. These three elements were not discovered at the time of Mendeleev. Because when he was making table, these three elements were not discovered one. And he just, we can say that these elements were there. He wrote there, and is the Ika boron. That we can say that is 44 is there. It was named as Ika boron by the Mendeleev one. Then second one was there, that is called as a Ika silicon. And third one was there. That is the, so far what we see about the merits on the first merit, what we see that in that table elements are successfully classified and placed in the table one. Second one was that we can say that we got the correct atomic mass number of the elements one. Yes, before the Mendeleev one, some elements were having the wrong atomic mass number one. That was corrected, the Mendeleev one. So we got the information that some elements, we can say, corrected their atomic mass number, like beryllium one. Then third merit was that he left three vacant places in the table one. In that table, he just wrote the numbers because these elements were, we can say, not discovered when he was making the table one. And these three elements were there. He named it as Ika boron. It's here Ika boron, here Ika aluminum, and here Ika silicon. Means 44 for Ika boron, 68 for Ika aluminum, and 72 for Ika silicon. These three names were there. He just wrote these three names one because these elements were not discovered at the time of the, we can say that, in making the table one. But as the, we can say that, he was studying the different reactions one, he came to know that there were three elements that were yet to be discovered, and their properties also, he said, is Mendeleev predicted even the, we can say, their atomic masses, even their different properties one, their densities one. So he predicted their properties of those elements one, and he just wrote their names Ika boron, Ika aluminum, and Ika silicon respectively. So, and soon that three elements were discovered one, and that three elements, then their names were replaced one. So this Ika boron was called scandium. Here scandium is there. Then Ika aluminum was called as, we can say, gallium. Here gallium. And here Ika silicon was called as the germanium. Scandium, then gallium, and germanium. So before the discovery only, he predicted that the elements, three elements, yet to be discovered. even whatever properties he predicted, that properties came true. So we can say that even though elements were not there, but he predicted there three elements present in the time in that we can say nature one, that yet to be discovered one, their properties will be like this. Whatever he predicted, that properties came true after the discovery of these three elements one. That was the we can say merit of this Mendeleev periodic table. So we can say that in that table we got the information about that. One more information is there when he made the table one at the last moment the zero group elements were discovered one. So what he did, he just placed that element to this right side here. So he made one more column, and in that column he made the we can say that he kept that paper elements one. So he could not we can say that he gave chance that undiscovered elements were to be kept one. Zero group elements he gave a separate we can say column for that. Like this we got the merit from this table. Again you see the merits one. The first merit we can say that he classified all the elements present at that time. Second was that we got the correct atomic mass number of the some element which were wrong one. He made it correct and then placed in the table one. Which means some atomic mass numbers were corrected from this table we got the information. The third was that if you see that the three atom places are there, these three atom places that these elements were not discovered one, yet he predicted the properties of these three elements one and he named as Ika boron, Ika aluminium and Ika silicon one for 44, 68 and 72 respectively. And soon after the discovery, then the names were changed. The Ika boron was called now scandium, Ika aluminium is called now gallium, and Ika silicon is called now germanium. And whatever properties predicted by the we can say Mendeleev was came true. It was true whatever he said about those elements. Then zero group elements were there. They discovered at the we can say that in the last moment one, but he did not disturb the table and he kept the we can say a separate column for the zero group elements. That was the merits of the we can say Mendeleev's periodic table. Now after studying this table one, now what happened? There are some we can say drawbacks are there. There are some anomalies are there in the table. Then that because of that anomalies, what happened? This table was again discarded. We see the lot of we can say efforts taken by this Mendeleev one in the last moment. This we can say the classification. This we can say theory was a discarded one. It is not accepted one. Now see why this are what are these drawbacks are there? What are these demerits are there? The first demerit was that if you see the first column in the first we can say that the period one, first group one. Here you can see that the lithium, sodium, then again we can say that the potassium, and then outside you can see here copper is given. Okay, so like these elements are kept in the we can say that the first group one. Now these elements are there, copper and we can say that this gold, silver. These elements are there. They are the we can say that the very less reactive one. So more reactive elements and less reactive elements are placed in the same group one. So we can say that these similar properties are not same, and the elements come in the same group one. That was the we can say that the drawback of that table one. Secondly, the hydrogen is there. Hydrogen, now suppose we can say that is placed here in the first group one. Now hydrogen, if it forms a compound one, it shows the properties similar to like this lithium, sodium, potassium. So it is kept here. But if you see we can say that the hydrogen, it also shows the similar properties like the 7 group. Here it is shown that fluorine, chlorine, bromine, iodine. So these elements are there. Along with the properties of these elements are again matched with the hydrogen. So the fixed place of hydrogen is not given, whether it is placed in the first group or whether it is placed in the we can say that the 7 group. That was the, we can say that, the drawback of the this vanillin chloride table, that is the second demerit one. Now the third drawback, that is the, we can say that the, here if you see in the table one, the cobalt, it has atomic mass number 59, then nickel also atomic mass number 59. Both have same atomic mass number, still they are kept in the different periods one. So whether cobalt is first or nickel is first, which we have to give preference, whether cobalt or nickel, there was, we can say, confusion in that one. So even though here it is given the same atomic mass number one, so which element will come first, it was not very clear in that one. So that was the third drawback one. Now fourth drawback is there. You know the one, there is the one, we can say, property is the isotope. These isotopes means what? The elements are there, the different forms of the same element, having similar, having the same atomic number but a different atomic mass number. There are the, we can say that, the different forms of the same element. Suppose if I say here about this carbon is there, there is a carbon 12, carbon 13, carbon 14. So this 12 atomic mass number, 13 atomic mass number, 14 atomic mass number, like this carbon. It is carbon only, but having different atomic mass number. So these are called isotopes. They have same atomic number. The atomic number is 6. The atomic mass number is 12, 13, 14 respectively. So these elements, even though now this table is based on atomic mass number 1, there should be place given for this, all these three. Here only the, we can say, place is given for only carbon, not for the, we can say, carbon 12, carbon 13, carbon 14. Most of the elements, we can say that most of the elements are there, they have the isotopes one. So we can say that in that table, the isotopes could not form the place in the table one. That was the, we can say, the biggest drawback of this table one. As the table is based on atomic mass number, each and every element, even if it is isotope one, the place should be given in the table one. As the place is not given for the isotope one, we can say that was the biggest drawback one. So because of these four drawbacks one, we can say that this whole table is discarded, is rejected one. See again, first the demerits one, what we have seen that these similar elements are there, these elements with the different properties one, they are kept in the same group one. I told you about that copper, silver, gold, they are less reactive one, while lithium, sodium, potassium, these are more reactive. But these are kept in the same, we can say that, group one. So that was the, we can say, drawback one or anomalies in that table one. Secondly, we said that the hydrogen could not get the fixed place, whether in the group number 1 or group number 7. As the, we can say that the hydrogen forms the, we can say that the elements like, we can say here, these halogens one, these are called halogens, and the properties of the hydrogen is similar to, we can say that, the alkali metals one. So whether hydrogen should be placed with the alkali metals or with the halogens one, that was confusion one. So that was the, we can say that the place for hydrogen is not given, that was the second drawback one. Then third drawback was that if you see cobalt and nickel both have same atomic mass number one. Since both have same atomic mass number, the places are given different. And in that also, we can say that the cobalt is placed first and then nickel one. Which will come first, whether nickel or cobalt, that was the, we can say, confusion one. That was the, we can say, third drawback in the table. And fourth very important drawback was that the table is based on atomic mass number 1. It means that isotopes should be given the place in the table. Isotope means what? We can say that the different forms of the same element, having the same atomic mass number, so having the same atomic number but different atomic mass number. Suppose carbon is there, carbon has atomic number 6 and atomic mass number is different, like 12, 13, 14. as the table based on the atomic mass number, they should be placed for the carbon 12, carbon 13, carbon 14. So most of the elements have the isotope 1. So places should be given to the isotope also. But here the place for the isotope was not given. So because of this code of demeasurable, this table is discarded one.